Question 8, JAM Chemistry. Calculate the volume in dm cube of oxygen evolved at STP when a current of 5 ampere is passed through acidified water for 772 seconds. Molar volume of gas at STP equals 22.4 dm cube. Good. This is a good question on electrolysis of acidified water. Good. What is acidified water? That's dilute tetraozosulfate 6 or dilute sulfuric acid. Now, when dilute sulfuric acid undergoes electrolysis, it's split into positive and negative ion. So H2SO4 will split into hydrogen ion and SO4 2 minus ion. So it will split to hydrogen ion and sulfate ion. So this is balanced like this. Good. Now, apart from the sulfuric acid undergoing electrolysis, water molecule 2, water will also split to hydrogen ion and hydroxyl ion. Good. So in this splitting, now after the ionization, we have only hydrogen as the positive ion, which will migrate to the cathode. Then the two of them will migrate to the anode, but not the both of them will be deposited there. Now it is only the hydroxyl ion. Why? Because hydroxyl is higher than SO4 2 minus in the electrochemical series for the negative ions. So that means this still need to undergo in the ionization process of this OH minus will lose electron because it has excess electron. It's going to lose electron to form water molecule and the oxygen molecule. So I can decide to move this E to this side to be positive. So now this equation is not balanced yet. So if I add 2 to this, the oxygen will be 4 and the hydrogen will be 4. Oh, that means I have to put 4 here. So now each one of these hydroxide ion will lose one electron, making 4 now. So that means we need 4 moles of electron to be lost. So now in this process, oxygen will be produced at the top of the Hofmann's voltameter. That's the instrument that we use in the electrolysis of acidified water, the Hofmann's voltameter. And the volume of hydrogen gas and oxygen gas produced in this process will be 2:1. So good. Now, knowing this fact, this is what we are going to use to complete the solution of the question. Good. Now, in the normal, we need to first calculate the quantity of charge used in this particular electrolysis. Q is equal to IT, which will be 5 ampere times 772 seconds, meaning that I stands for current and T stands for time. So we are giving current as 5 ampere and time as 772 seconds. Let's multiply that together. If we multiply 5 times 772, 5 times 772, that gives me 3,860 coulomb. So that's the quantity of charge that we need in this process. Now, for normal, for 4 moles of electron, we produce 1 mole of oxygen gas. So 4 moles of electron will produce 4 moles of electron. So now for 4 moles of electron, we need 4 Faraday. So that's 4 times 96,500 coulomb. So of electricity. So 1 Faraday is 96,500 coulomb of electricity. So 4 electrons, that means 4 of it will produce 1 mole of oxygen gas at STP. And 1 mole of oxygen gas at STP has the volume of 22.4 dm cube. This will give 22.4 dm cube of oxygen. Good. So we don't know how much this quantity of charge will produce. 3,860 coulomb will produce x dm cube of oxygen gas. We can cross multiply here to have 4 times 96,500 coulomb times, let me remove coulomb, times x will be equal to 22.4 times 3,860. Let's divide both sides by 4 times 96,500. X will be equal to 22.4 times 3,860, all divided by 4 times 96,500. That will be equal to, so let's multiply that with our calculator. 22.4 times 3860 equal divided by 4 times 96,500. So that gives me 0.224 dm3. So that means my final answer is option B. Thank you.